Okay, now we want to talk about how can different molecules hook together to make a larger structure. And so here are four different examples of molecular bonding. And of these four, you only need to know two of them for purposes of the exam. And then I will just show you the other two in case you're interested. And you are interested, right? Yeah, I hope so. And so the first one that I want to show you is, why does water stick to itself? So you know that if you have steam and you lower the temperature on steam, eventually the water molecules will start to attach to each other, and then you'll have liquid droplets of water. So we want to know, why is this true? Okay, so let's go back to oxygen, and we're going to talk about water. And you might have been wondering, why does water have this particular shape associated with it? So you might be thinking, well, it ought to look like this. So we put the two hydrogens on either side of it, but it turns out that that's not correct. And so let's see if you can figure out the reason why it's going to be shaped the way it is. What did we say was the magic number in chemistry? Okay, the magic number was 8. And one thing that happens in quantum mechanics is the electrons really like to pair up with each other, so that if you've got pairs of electrons and the total number of electrons is 8, then that means you have how many pairs? You would have 4 pairs of electrons. So if you've got, let's say if you had only 2, it's true that this would be the correct way of thinking about things. If you had 2 objects and you want to get them as far away from each other as possible, why? Remember that this one has a charge and this one has a charge, and they would repel each other. So you'd want to put them on opposite sides. What if you had 3 charges? What would it look like? If you had 3 things that you wanted to surround the oxygen with, now this isn't right, but this is what it would look like. It would be a triangle. And what would happen if you had 4 things? Well, you might be thinking, let's make a square. So you got 1, 2, 3, and 4. But that's what it would look like if it was in a plane. But you have to think 3-dimensionally. And if you think about it 3-dimensionally, what happens is, let's put the oxygen here, you'd have 1 on the top, and then you'd have 3 of them on the bottom, and they would make a triangle like this. And so it would make a pyramid. And so now let's go back to our original picture for hydrogen, which had for water, which had 2 hydrogens. So let me get rid of this one, and then let me get rid of this one, and lo and behold, here's our picture that had the 2 hydrogens, and it kind of looks like they're going at an angle like that. So this angle is approximately a 60-degree angle. Don't worry about that, but this is the reason why water is bent the way it is. Okay, now hydrogen had an electron, and then this one has an electron, and then oxygen had 6, so 1, 2, 3, 4, 5, 6, and then this hydrogen here is grabbing onto those 2 electrons. This hydrogen's grabbing onto these 2 electrons, and oxygen is grabbing onto all of them. It's a tug of war. But oxygen is bigger. It's a bigger atom than what hydrogen is. It's got more electrical pull because it's got more protons in its nucleus. So that means the electrons spend more time around oxygen than they do around the hydrogen. So that means that this side of a water molecule tends to be negative, and then this side of a water molecule tends to be positive. We say that the water molecule is polarized. A magnet is polarized. A magnet has a north pole and it has a south pole. So similarly, this thing has a negative side to the molecule and a positive side to the molecule. Now, if you add the two together, it's electrically neutral, but the charge has been separated. So this is going to be called an electrical dipole. And now, who cares? So now, let's say that you have this water molecule, and now you have another water molecule over here. So, well, we can do it here. So let me just get rid of this and this and this. So let's say that you've got two water molecules that are approaching each other. Then this negative part of this water molecule is going to be attracted to this part of this water molecule. So the two of them will stick together electrically. And now what we've done is now we have created liquid water. So they're stuck together in a clump, and now we've got liquid water. Another interesting thing, you can see it in that picture there, is as you decrease the temperature of the water, you know that water changes first from a gas to a liquid, and then from a liquid to a solid. And so what will happen when it's a solid is you will have 6 water molecules, and they make a hexagon. You can see it if you look at that picture there, that 6 water molecules will form a hexagon, and it'll have an open space in the middle. So do you remember when you made snowflakes in elementary school, and you folded up the piece of paper and then you cut it and then you opened it up? It made a how many sided snowflake? It made a 6-sided snowflake. So that when water freezes, it makes these little hexagons. Inside the hexagon is an open space. And so that lowers the density of water, which makes it do what when it's frozen? So an ice cube will float in water, and that's the reason why. So this is why having an understanding of atoms is so very important. Even if you don't understand the mathematics, if you understand it at a conceptual level, you can explain a lot of things that happen in nature. So this was one example of how to make a substance by gluing together molecules. All right, now the next one that you need to know for purposes of the exam is going to be, how can water pull things apart? Water is a solvent. We use it to clean our dishes, and we use it to clean laundry, and water is in every cell of your body, so chemical reactions take place in water. What's so special about water? So the bottom picture there shows salt, and salt is going to be NaCl, and so it's got a positive part to it, and then it's got a negative part to it. And so what water can do is the positive end of the water can be attracted to the chlorine, and it pulls the salt apart. And then the water will surround the salt, will surround this chlorine. And then, similarly, the positive end of the negative end, so this up here, the negative end of this one is going to be attracted to the positive sodiums, and it's going to surround it as well. So eventually what will happen is water has the ability to pull apart salt and surround it, and so now the salt has dissolved in the water. And it all has to do with the positive and the negative aspects of it. Okay, and then let me just mention these other two to you, and it's pretty interesting stuff. I think it's interesting. And an example of this is, let's look at oxygen. So oxygen in the atmosphere is O2. So that means that you have an oxygen and then you have an oxygen. And so what happens is each oxygen is going to have 6. So it's going to have 1, 2, 3, 4, 1, 2, 3, 4, and then 5 and 6, 5 and 6. So this is called a double bond. So you got a bond there and a bond right there. So here's your oxygen molecule. But the thing about it is that sometimes the electrons spend more time on this side of the molecule than they do on this side over here. So that means that for a split second, this side of the water molecule could be negative, and then this side could be positive. Just for a split second, and then it goes neutral, and then maybe for another split second, it could be negative on this side, and it could be positive on that side. Who cares? So now let's say that you've got 2 oxygen molecules. So you got oxygen molecule here, and you have oxygen molecule right here. And as they get closer together, it might just happen that this side is positive for a split second, and then this side is negative for a split second, and then the 2 of them will go together, and now you have a conglomerate of oxygen when that happens. This is how you get liquid oxygen. Have you ever heard of that? Normally, oxygen is a gas, but if you turn down the temperature on oxygen enough, what will happen is the oxygens will start to stick to each other because of this. So this is called a van der Waals force that does this, and then you end up with liquid oxygen. Cool. And then the one that's on the bottom and over on this corner is yet another kind of bonding, and this one is going to be called hydrogen bonding, in which you've got some kind of a molecule over here that just happens to have hydrogen on it, and it's going to see this very electronegative atom, and it's going to be attracted to it. And so this is a very, very weak bond, but this is what glues your DNA together. So if you want to take that picture and blow it up so that you can see it a little bit better, you'll notice that what is holding one string of DNA on this side to one string of DNA on this side are hydrogen bonds. Okay, so those are 4 different kinds of ways that molecules can be glued to each other. All right, let's take a break, and when we come back, let's talk about some practical applications of what we have just finished talking about.